So the first one I want to do, this thing off, dang. This question is not one of the questions on your deal because there's not very many questions on that acceleration practice. I wanted to work through one showing you the formula up here. Does it tell you the formula at the top?
Yeah.
It does? Okay, good. Even if it just tells you that acceleration is change in speed divided by time, I wanted to show you a little bit more. Google Forms won't let me say VF with the F and a subscript. And what I mean by that is I have my acceleration formula up here. I'm pretty sure they can see this. VF with an F in the subscript and VI with an I in the subscript. As I think I mentioned one other time, this stands for final velocity, V sub F, and this stands for initial velocity, V sub I. Can y'all see that way back there? I tried to write it big, but it's in red. Let's see. Okay, that's about where that bar is. All right, so let's do one of these. This is one that might be kind of difficult, and I know I haven't done examples of algebra with addition and subtraction yet, so let's check it out. If a car has a constant acceleration of 4, it just told us acceleration, so I wrote the formula, just the letters, and now I got write down acceleration, 4 meters per second, or meters per second squared. And okay, acceleration of 4 and starts from rest. What's that mean? Which one is 0? We got two different velocities now.
VI.
That's VI, it's the initial one. You know the difference between VI and VF is you look at where the words from and to are. It doesn't always give them in order, so you have to read carefully. Like this one says, I'm about to try to move the board so they can see the whole thing. I don't even know if they can read this. I think they probably can. This one says from rest first, but it could say if it goes to this speed, if it goes to 5 meters per second or something, to rest, then wait, to 5 meters per second from rest, that would still mean the rest happened first. It just said it's second. You're going to pay attention to where the words from and to are to get the sequence of events right in your story. So it's like physics is a whole lot of different subjects. We got to draw pictures, diagrams, and stuff. And to get these questions right, you got to use things you learn in reading, critical reading stuff. Anyway, if it starts from rest, initial velocity is 0 meters per second. All right, so acceleration is meters per second squared, velocity is meters per second. We want to make sure we get those right. And then it asked, how fast is it traveling after 5 seconds? It says after twice, whatever. I'll put the 5 seconds first, I guess. That's a time, so t equals 5. And it's asking how fast is it traveling after. That after is a key word for us. Just like from up here was a key word telling us that's initial velocity is 0 because it says from rest. How fast is it traveling after? That's a key word to tell us it's asking for final velocity because it says after.
After twice.
It says how fast. Yeah, I typed it twice. Thank you. Okay. So it's asking for final velocity. Remember, say VF equals blank. It's going to really help not to put a question mark or an X there, in my opinion. As we get to more variables, we got 4 variables already. We're going to get to 5, and then one of these days is going to be 8, but it's going to be a minute. I better sit down because I'm too tall. All right. So there we go. We got 4 for acceleration. Second squared. Final velocity, that's what we're looking for, so I just write VF. VI is 0, well, that's going to be easy up there. And time is 5. Now remember, everybody, can you see me? Remember, if we were looking for time, you don't want time to be down there. Either, you don't want time to be down there. You should get it out of there first. So it says divided by, if we were looking for time, the way to get time out of the denominator, if there was just a t here, if we were looking to make it say equals t, you multiply both sides by t. But we're looking for VF up here, so we don't need to worry about that. But be careful. All right, so we need to get VF by itself. The first thing we need to do is get rid of this 5. If this were a number up here, we shouldn't add it to both sides first because it's still technically a fraction. Like it's VF over 5 minus 0 over 5 right now, which if it were a number, that would mean something more, but that wouldn't work. I'm gonna have to make a new video. This one's not good. So to make this 5 cancel, we need it to say equals VF. To make this 5 cancel, we need to multiply both sides by 5 first. Multiply both sides by 5. One on bottom, one on top. Oh, and that's 5 seconds. So VF minus 0 is just VF. So I guess we can say VF minus 0, and then that is equal to VF, so we're fine. Notice I'm keeping my equal signs lined up, keeping organized over here. 5 times 4 is 20. And I've got a seconds on the top here because that's just 5 seconds. And then I got per second down here, so I can cancel one of those seconds with that second. And so my answer is in meters per second. So 20 meters per second equals VF. It's also possible to do this in your head, I think. If it accelerates by 4 meters per second each second, and it goes for 5 seconds, after the first second, it's going 4 meters per second. After the second second, it's going 8. And then 12 after the third second. And then 16 after the fourth second, and 20 after the fifth second. So you can just think about it like that, because it's speeding up by 4 meters per second each second. But when the numbers are more difficult to think about, like if this were 4.2, then you might have to write it down. I hope that helps. Who's there? I have to edit that video.